we are group 12. I'm Melanie Vu.
I'm Ricardo Sanz.
I'm CJ White.
I'm Yongmei Chen.
And we did our project on Spotify. The company was founded in 2006 in Stockholm, Sweden by Daniel Ek and Martin Lorentzen. Ek was a successful entrepreneur and he wanted to develop a way to integrate music and technology, two of his favorite passions. He teamed up with Lorentzen, who helped fund the project, and they created an app that would provide millions of songs for free. Spotify also offers a premium version of Spotify. Currently, there are 248 million active users and 113 million premium subscribers. There are 30 million songs from 1.2 million artists available, and they operate in 65 countries. This is Spotify's mission statement. The idea is they want to connect artists and their fans in an organic and creative way. They're hoping to grow and innovate Spotify in ways that aren't in conventional means. Spotify provides a free service for users to access their favorite artists and musicians. You can access Spotify through your computer, your phone or your tablet, a game console, or a smart TV. You can utilize Spotify by listening, streaming, or sharing music. You can access it 24 hours, 24/7, and Spotify's algorithm suggests songs for users to play once they hit the end of their playlist. And non-premium users will have to listen to a 30-second ad every 15 minutes. For our scope, we chose to have the requirements users have to register their username or email address and enter a password. Users have to be able to search for songs and add those songs to a playlist. So our requirements included 5 tables: Spotify user, song, playlist, selected song, and artist.
Okay, I'll try to explain you the conceptual model, but before that, I would like to express my formal gratitude to my group. I could learn a lot in these last 60 days with Melanie, May, and CJ. Really was a pleasure and couldn't be a better group. Okay, conceptual model, how it works. A Spotify user can have many songs, but each song is added by one Spotify user. Many songs can be added to many playlists, and many playlists can have many songs. A Spotify user can have many playlists, but each playlist is added by one Spotify user. Users can search a song and put it into a newly playlist, or the opposite. The users can create a playlist and add songs. We need to identify and pick it up one method. We choose how you can see Spotify users choose songs and add these songs at a playlist. This was the way that we choose. More interesting components, as you can see at the artist name, the double circle means multi-valued artist, and with playlist entity type. More than one artist can be featured on a song, forcing the creation of another relation. Need to determine another primary key to uniquely identify a playlist.
Okay, so I'm going to talk about the logical model for our database. So this gives the basic rundown of our primary and foreign keys. As you can see, the user ID is a very important attribute for our database. And this model that shows the importance of the user and song tables in the stability of the database. 3 of the 4 tables have foreign keys and primary keys to the user and song tables. And the largest table is the song table due to the amount of info that needs to be stored. The reason we originally started with 3 relations, but we needed to add 2 additional, the selected song and artist, as Ricardo had said that we had a multi-valued. And the selected song, we needed that to be able to tie in our song and our playlist relations. And we also needed to add an artist because that represented our multi-valued attribute. This is a visual representation of our physical model and the data types that we used within our database. So we used a varchar as well as a date data types for our physical model. Those members of our group familiar with the app solved our circular reference problem between the Spotify user, song, and playlist tables. And we went through the app and narrowed the steps of the process to create a playlist.
So in our SQL database, we created 5 tables according to the logical and the physical model. So we have the Spotify user table, the song table, the playlist table, the selected song table, and the artist table. So for the database, we created the table and added in the constraints such as the primary keys and the foreign keys to link the tables together for the future queries and the searching functions. So also for the sample data, we inserted 14 songs for the source data. I researched from the internet and gathered the song information such as the attributes like the song name, the song length, the artist names, and the release date, and so on. So we selected the songs from the internet, and also for the customer, for the Spotify user tables, I made up the information. It's like the name and the email address is made up information. So we inserted that as a source data. So in the tables, we have the source data and have the constraints to link them together. And then we can, after we have the songs, and the user have the songs and then can put into the playlist. That's the table example. This is the Spotify user table. So we have the name and the email address and the user ID. And then that's the song table. So we have 14 songs as the source data in the song table. We have the song ID, name, and album name, and the like genre, what different categories. And that's another example of the table. That's the song table. So you can see we have the ID, the song name, and the attributes listed on there. And then that's the playlist table. So for the playlist, the user can have the playlist and then can put the song they like to the playlist. They can listen later. That's the playlist table. So I created 2 playlists. One is named My Favorite, another is popular playlist. It's popular song. So that's 2 kinds of playlist. So we have the playlist. The information includes the user ID, the created date, and the category. And that's the song of the table, the table of the song. So we have the primary key and the foreign key. This table stores the data for the song information. That's the example of the song table. So, okay, that's the artist table. We have this table because the artist attribute is the multi-value attribute. So we have to have this table to store the different artist name in there. And that's the sample of our SQL table. So you can see we have the different artist name and for the song ID, because one song can have many artists, and that's the multi-value.
So our database is currently functional. Users can register themselves, they can search for songs, and they're able to add songs to a playlist. Future ideas that we weren't able to accomplish in this project because it was out of the scope was how Spotify has advertisements, the types of songs that users can select, whether it's by artist, album, or genre, how Spotify configures sponsored songs and artists, their algorithm on how they suggest songs to the user, how to register for the premium version, which includes ad-free songs, be able to skip songs and download offline music, and then the ability to share playlists and podcasts. Thank you for listening.